Okay, here's question 7 from the mock. It says the diagram shows the sketch of a curve and the tangent to the curve at P. The curve has equation y equals 4 minus x squared minus 3x cubed, and the point P is minus 224, and we're told that P lies on the curve. The tangent at P crosses the x-axis at Q, so you can see all that's drawn on there. Find the equation of the tangent to the curve at the point P, giving your answer in that form. Giving your answer in that form is how you're going to rearrange it once you've subbed it into your y minus y1 equals mx minus x1. So because it's a tangent, it's a straight line, so we can use that equation. So we need to find our gradient and our point. Alright, we've got the point P because it's the tangent at that point P that we're looking for. So I'm looking for the gradient. Now the gradient of the tangent, by its definition, the tangent at the point when it touches the curve will have the same gradient as the curve at that point. So if we find the gradient of the curve at P, that is the gradient of the tangent. So to find the gradient of a curve, we can't do change in y over change in x because it's a curve. So the other method that solves this problem is differentiating. Okay, so we've differentiated the curve. The 4 would disappear, the 2 would come down in front, so I'd end up with the minus 2x, don't forget that minus. The 3x cubed term, the 3 from the cubed would come down in front to make minus 9, and then the power would reduce to the 2. Okay, so we need to find the actual value of the gradient at the point P. So at the point P, the x-coordinate is minus 2, so if we sub that in. Okay, so you see we've subbed in minus 2 there. So minus 2 times minus 2 is plus 4. Minus 9 lots of minus 2 squared. Well, minus 2 squared would be positive 4, which would give me minus 36. And that would give me the gradient of minus 32. So we've got the gradient of the tangent. We've got the gradient of, we've got a point. So we just sub them into y minus y1 equation. Okay, so subbing them in, we get y minus 24 equals minus 32, x minus minus 2, which was why I've written a plus. Expanding the bracket and adding the 24 to the other side, and then simplifying the minus 64 and the plus 24 gives me y equals minus 32x minus 40. I've expanded the brackets because remember in the question it said in the form y equals mx plus c. Y equals mx plus c. What will help you kind of have some confidence as to whether this is right is if you look at the line, the tangent, it has a negative gradient, which mine has. Where would it cross the x-axis? Well, it would cross kind of quite low down in the negatives, minus 40. Yeah, it all makes sense. If, for example, you got a positive gradient or you'd got a positive y-intercept, then alarm bells need to ring because that wouldn't make sense for that graph. Okay, A part 2 says hence find the x-coordinate of Q. There's two things to tell me that I'm going to use the equation that I've just found. The fact that it says hence, the fact that it's A part 2 suggests that it's all part of one question. So even if you don't necessarily understand the maths, which obviously I'd never encourage you to, we want to understand what's going on, but even if you didn't understand what was going on, just look at it. It's A part 2, so it's a subsection of part A, and it says hence. Hence is saying what you've just done, do something with that. Alright, so thinking about all those things, the x-coordinate of Q. So if we look at Q, Q is where, and we're told, it's where the tangent crosses the x-axis. So it's where that line we've just found the equation of crosses the x-axis. So there's the answer from the last section. What could it mean? Where does that line cross the x-axis? Well, we should know that when a line crosses the x-axis, that's when the y-coordinate is 0. So if we sub in y is 0, rearrange it and solve for x, it will tell us that x-coordinate Q. Okay, there you go. So I always like to say when y equals 0. Tell the examiner the scenario, what you're doing, explain to them, show them that you really understand it. So when y equals 0, so we've subbed that in, we've then solved for x. And we found that x is minus 5 over 4. Again, if you'd got a positive value there, would you have been happy? Look at the graph, no. Okay, we're expecting that value. We're also, look at where it is in relation to p. We know the x-coordinate of p is minus 2. So if we'd have got minus 10, alarm bells again. It wouldn't make sense. Okay, so always look at your answer, does it make sense? Okay, part B. So part B is saying find, and then we've got the integral sign with some limits, and you'll notice that it's the equation of the curve. So it's not asking us to find an area as such, it's just asking us to evaluate that. So you'd integrate, sub in your limits, and then you'll see that later on the second part is where you're actually finding an area, so don't worry about that for now. Okay, so I've integrated. As soon as you actually integrate, the integral sign needs to go. And then your square brackets appear, and then you put your limits on the right hand side. We don't need the plus c because that would be in each bracket and it would cancel out. So you only need to put the plus c when you don't have the limits. Okay. So the top limit goes in the first bracket and the bottom limit in the second. I always use additional brackets, especially when you've got negatives. If you don't do that, you will make mistakes. Okay, so getting rid of those smaller brackets, I'm left with that. And then here's the final bit of working out. So I've expanded this second bracket, so basically because we've got the minus, each sign inside would change. What I've noticed first is that I can bring my whole numbers together. My minus 1/3 and my minus 8/3 nicely is minus 9/3, so that becomes minus 3. I then got my 21, and then I've got minus 3/4. So I've kind of simplified it as much as possible before dealing with the fractions. I want 21 to be written in terms of quarters, so that would be 4 lots of 21, so it would be 84 over 4 minus 3/4, leaving 81 quarters. Okay, B part 2, so again it's a follow-on from B part 1. It says the point R is 1, 0, lies on the curve. Calculate the area of the shaded region bounded by the curve and the lines PQ and PR. What you need to think about is what have I done in the last part? Why was that B part 1? How is that leading me on to B part 2? Well, if you look at the limits here, we've gone from when x is 1. So when x is 1 is the point R. And we've gone from when x is minus 2. And minus 2 is the point P. So what we've actually done in that first bit, if you look at this picture I've put on here, we found the area of that region there, because P had the x coordinate minus 2. So what we need to work out is the area of this triangle, and then remove that from the 81 quarters, which was the answer to that. So I've just drawn that triangle out with the point P up here, which we know the coordinate of. I know that the x value there is directly below P, so it would be minus 2. And then the triangle comes down there to Q, which we worked out in A part 2 has coordinate minus 5 over 4, 0. So we're just finding the area of that triangle. So I need to know this length, and I need to know this length. So this length, well, what's the difference between minus 2 and minus 5 over 4? Well, minus 5 over 4, if you'd prefer to think about it, is minus 1.25, so it's 0.75. That length would be 0.75 or 3/4. And this length, well, it's from the x-axis up to when y is 24, so it would be 24. So you can have 24 times 3/4 divided by 2. Okay, so you get an area of 9 for the triangle. So then the shaded region would be the answer from part B part 1, 81 quarters minus 9. Okay, so subtracting 9 from the 81 over 4, we get 45 quarters.